All right, let's jump straight into the future. I want you to imagine, for a second, that it's March 5th, 2026. What we're talking about today isn't just an update. It's probably the biggest shift in how we use computers since the original iPhone. We're moving past screens and into a whole new world of holographic glasses that are powered, well, by our thoughts.
And right off the bat, let's just get one thing crystal clear. That whole era of those bulky, heavy headsets from back in 2024, it's over. Done. That entire approach, it turns out, was a total dead end. But the big question is, why? What went wrong?
See, it wasn't a matter of needing better software or, faster computer chips. The real reason the whole ski goggle approach failed came down to two problems that you just can't get around. They're rooted in the basic laws of physics and our own biology. Let's break them down.
So first up, there's just simple, brutal biomechanics. Picture strapping over half a kilogram, that's more than a pound, directly to the front of your face. This creates something called neck torque. It's this constant pulling force on your spine. And the result? Well, after just an hour or so, you'd get serious muscle strain and fatigue. It just wasn't physically sustainable for anybody to use all day.
The second problem was a little more sneaky. It's called the Virgin's Accommodation Conflict, or VAC. Basically, your brain gets totally confused. Your eyes are trying to converge on a hologram that looks like it's way across the room, but at the same time, they have to physically focus on a screen that's literally inches from your eyeballs. This mismatch, this sensory glitch, is what was directly causing all that motion sickness, the headaches, and the eye strain that so many people complained about with those early headsets.
And this is the really critical point here. These issues weren't just simple design flaws that you could fix in the next version. They were fundamental roadblocks. Better cameras or faster processors can't change the laws of gravity, and they can't rewire how the human eye works. A completely different way of thinking was needed.
Which of course leads us to the million-dollar question. If the ski goggle was a dead end, what was the giant leap forward that finally unlocked the future of augmented reality? Well, the answer was actually a two-part revolution, changing both the hardware and how we interact with it.
And wow, this cable really just says it all, doesn't it? Look at the difference between 2024 and 2026. The weight plummets from over 600 grams to under 120. The way you control it goes from cameras watching your hands to something totally new, neural wristbands. And that isolating video feed of the world was replaced by real, see-through holographic glass. Let's dig into that new input method first.
Believe it or not, the single biggest breakthrough didn't happen on the glasses at all. It moved down to the wrist. We're talking about the end of physical controllers, the end of clunky camera-based hand tracking, and really, the beginning of controlling computers directly with our minds.
So, how in the world does this magic actually work? Well, it's a technology called electromyography, or EMG for short. See, before you even move a muscle, your brain sends a tiny electrical signal down your arm to your hand. This wristband is designed to pick up and decode that signal milliseconds before your finger even has a chance to twitch. It's not reading your mind, it's reading your intention to move.
And the only way to really describe what it feels like to use this is like digital telepathy. You think about clicking a button and the click just happens. You think about scrolling down a page and the page just scrolls. There's no visible movement required at all. What this unlocks is this incredible concept called micro-gestures. You could be sitting on a train or in a meeting with your hands resting perfectly still in your lap, and you could be typing a full email on a holographic keyboard or manipulating a 3D model that only you can see. It is completely silent, subtle, and nobody around you would have any idea you're doing it.
Okay, so that solves the whole input problem. Pretty amazing. But how did the glasses themselves get so light and, well, so normal looking? The answer there is a total revolution in the hardware architecture.
The big secret was to stop trying to cram a supercomputer into the glasses themselves. Instead, designers got smart and used what's called a distributed compute model. The glasses basically became these hollow shells that only hold the displays and the sensors. All the really hard work, the heavy processing, the graphics, the AI, that gets offloaded wirelessly to a little device you keep in your pocket, kind of like your phone. And that's it. That's the trick to how you get a super powerful AR device that weighs less than a normal pair of sunglasses.
And then on the software side of things, they just completely abandoned old-school video game engines. They started using new AI-powered rendering techniques. Paired with incredibly fast eye tracking, it means the system only renders the world in full max detail, exactly where your eyeball is pointed. Everything in your peripheral vision gets a lower res version, but here's the thing, your brain literally cannot tell the difference. This technique is called foveated rendering, and it saves a truly massive amount of battery and power.
So we've got these incredibly light glasses, and they're controlled by our thoughts.
The technology is it's mind-blowing. But what does it actually mean for how we live our lives, for how we work? This new reality, it brings both some amazing promise and some really serious peril.
On the good side, you can say goodbye forever to those flat, exhausting 2D video calls. With something called codec avatars, a new kind of AI creates a perfectly photorealistic 3D version of the person you're talking to. It captures every little microexpression, every nuance, and creates a genuine feeling of telepresence, like you are actually sitting in the same room together.
But of course, this kind of power is a real double-edged sword. I mean, on the one hand, you have this unbelievable telepresence and this seamless way to blend digital information with your world. But on the other hand, you've got the risk of becoming totally isolated from your physical surroundings and a new, much more invasive kind of advertising.
And this is where things get really, really serious. Eye tracking is the ultimate privacy frontier. Think about it. This data doesn't just show an advertiser what ad you clicked on. It shows them what you wanted to click on. It shows what your eyes lingered on, what caught your attention, what your subconscious mind desired, maybe before you were even consciously aware of it. This is a tool for predictive behavioral engineering on a scale we have never seen before.
So, weighing the unbelievable potential against these profound new risks, where does that leave us? What is the final takeaway from this incredible paradigm shift?
Well, ultimately, the conclusion is this. The technology functionally erases that rigid barrier that has always existed between the digital world and the biological one. The future of computing, it isn't on a desk, it's not even in your hand. It's ambient, it's spatial, it's all around us, and it's controlled by the silent intention of our own nervous system.
Which leaves all of us with one last and really crucial question. This line, the one that has defined the human experience for our entire history, it's dissolving right in front of our eyes. The question is no longer if this is coming. It's here. The real question is, are we ready for what happens next?